Hey guys, this is Ms. Regine from Soar Educational Services, and today we are going to do one of these optimization constraint problem that you often see in Algebra 2. So I will read it first. It says, I can print a t-shirt in 20 minutes and a hoodie in 30 minutes. I work a maximum of 24 hours a week, and I want to print at least 45 t-shirts. The profit from a t-shirt is $18 and the profit from a hoodie is $22. And basically the question is, what is the maximum amount of t-shirt and hoodie that I can print to maximize my profit? So that's how these problems always work. So the first thing is, we have minutes. You print t-shirts 20 minutes and you have hoodie for 30 minutes, but the maximum time you're working per week is 24 hours. So what we want to do first is change those 24 hours to minutes. So that means I'm going to be working 1,440 minutes. So, and we're going to set X equals the number of t-shirts. So X equals t-shirts and Y is for hoodies. So in 20 minutes, I make one t-shirt, so X t-shirt will times 20 would be however I can make, with my time constraint, and 30 minutes for hoodies. Well, that I want it to be less than or equal to 1,440 because the maximum I'm going to work per week is 1,440 minutes. So that's one of my constraints. My other constraint is that I want to print at least 45 t-shirts. So remember, X is for my t-shirts, so X has to be greater than or equal to 45. And I want to know what the maximum profit is that I can make. So this is going to be the equation I'm going to use for my profit maximization. So $18 per t-shirt and $22 per hoodie. So what I need to do is so this equation 20x plus 30y is less than or equal to 1,440. What I would do is change it it's in standard form, so I need to change it to slope-intercept form. So I'm going to erase, and you can try this on your own and pause the video and see. So to change it to slope-intercept form, I would move the 20x over, so divide by 20. Subtract 20. You subtract 20x on both sides. So when I move the 20 over, it'll be negative 20x plus 1,440. And we have 30y. And now we would divide by 30. And divide this by 30 and divide this by 30. And that simplifies to negative 2/3 x. And this simplifies 1,440 divided by 30 simplifies to 48. So now I have this in a better way to graph it. If it's in standard form, you can also graph using the X and Y intercept. That is one other way, because if you just have the X and Y intercept, you can just plug it in and connect the 2 points. But I usually change things to slope-intercept form, but you could solve for the X and Y intercept and connect the 2 points and then draw a line. That would work too. So now we have this, and then we have X is greater than or equal to 45. So I already did this graph, and okay, so here it is, because I did it on paper because it was very large. So if you notice, I just used a scale from, on my x-axis, it's from 0 to 80, and my y-axis, I think it was 0 to 48, and I did 48 because that was my y-intercept, that was the highest. This diagonal line that's going down, that's this equation, y is less than or equal to negative 2/3 x plus 48. So if you notice, I started at 48. I did use intervals of 2. So it took a while. In fact, the first one, I made a mistake, so I had to start all over. So these can take a while, and you have to be very meticulous about it. So I counted by 2, but I used, I would, just go down 2, across 3, down 2, across 3, and so on. So, but like I said, you could have done the X and Y intercept. That could have been something that also would work, because then you would just have 2 points. Maybe it would be less work that way too. That might be something for me to try another time. So, but I did just use the equation and then just went all the way down. And then this vertical line right here, that's this one. X is greater than or equal to 45. So what I have shaded in pink is, okay, this is the greater than, so it's to the right of that line, X is greater than or equal to 45. And what I have shaded in blue is for the other constraint of the time constraint. So that was my negative 2/3 X plus 48. So where your possible answers are is where the pink and the blue meet. So there's a triangle below where the pink and the blue meet right here in this region. So those are my possible answers. So one possible answer is 4518, another possible answer is 450, and the other one is 720. So now that you have your objective function, which is right here, 18x plus 22y, what I need to do is to plug in into each of those, my possible values. So I can do 18 times 45 plus 22 times 0 and see what that gives me. So 18 times, let me try that again, 18 times 45, that's 810. So if I make 45 hoodies and 45 t-shirts and 0 hoodies, that would be one possibility. And I would make $810. I could do 45 t-shirt and 18 hoodies. And let's see what that gives me. So we have 18 times 45, which is, oh, we already did that, 810, and 22 times 18, which is 396. Add that up together, and that's 1,206. And my other possibility is to make 72 t-shirts and no hoodies. All right, so 18 times 72 is 1,296. So while it wasn't bad to make a combination of t-shirts and hoodie, so 45 t-shirts and 18 hoodie would get me 1,206. If I'm trying to maximize my profit, it's worth it to just make 72 t-shirts because they're quicker, and I would make $1,296 and no hoodies. I still work the same number of hours and I get the most for that. So this is how you would solve one of these problems to optimize your function and see what's the maximum profit you can get. I hope this was helpful, and I'll see you next time. Bye.